And there comes a question based on electrolysis which says, predict the products of electrolysis in each of the following. 1. An aqueous solution of silver nitrate with silver electrodes. Now, what happens? See, in case 1, at anode, if you have silver electrodes, then silver gets oxidized, preferably as compared to water or anything else. So new silver, the anodic silver, actually reacts and dissolves in water, forming silver ions. And then what happens at cathode? Now the solution has plenty of silver ions. So silver ions just take up electrons and get deposited. So Ag at anode just gets transferred to Ag at cathode, and nothing new happens when we are talking about electrolysis products, when silver nitrate aqueous solution is electrolyzed using silver electrodes. Beautiful but simple. And you know, this reaction is used very much in electroplating of silver. Say for example, at anode you dip a silver rod, and at cathode you're having a spoon or a plate or a statue. Can spoon or plate or statue function as electrode? Yes, they can. You just have to pass current, that's it. So you would find that silver rod would dissolve at anode, and slowly silver gets deposited at cathode. Maybe it's a spoon. So although the spoon might have been an iron spoon, but as silver gets deposited, it begins to look like a silver spoon. It now becomes a silver coated spoon. Electroplating is a very popular thing which is done using electrolysis like this. Second, an aqueous solution of silver nitrate with platinum electrodes. Oh my God, now this is going to be a mess. Why? In the second part, if you're using platinum electrodes, now platinum is very inert and unreactive. Platinum at anode would not undergo oxidation. Now, since nothing else is there at anode, water will have to undergo oxidation. Poor water, it undergoes oxidation to give you oxygen, to give you electrons, and of course, free H plus ions. And what happens at cathode? Well, at cathode, you have Ag plus ions shamelessly eating away electrons to give you silver. If you add, what do you get? Multiply by 4 in the cathode reaction and add, you get 4 times Ag plus 2H2O, giving you 4 times Ag plus 4 times H plus O2 like this. So what happens? Products of electrolysis, you find at anode, acid, H plus is acid and O2. At anode, O2 and H plus is liberated. At cathode, silver gets deposited. These are the reactions which occur during electrolysis of silver nitrate aqueous using platinum electrodes. The third one says a dilute solution of sulfuric acid with platinum electrodes. Now this gets very interesting again. Why? Because at anode we have to make some kind of an oxidation, and anode attracts anions. Now anion which is attracted at anode is sulfate, and sulfate is not any anion which easily undergoes oxidation under normal circumstances. So please leave H2SO4 out. It is water, the poor water, the very reactive, not reactive but very, you can say very brave water which comes to rescue. It says, no, I will undergo oxidation. Water gets oxidized, liberates bubbles of O2 acid and gives away electrons. And what happens? Because we have H plus ions, these H plus ions thanklessly eat away all the electrons, and what you get actually is this. 4 electrons, 4 H plus. In order to multiply, add them properly, electrons must cancel. So I should multiply the lower equation by 2, add up. What do I get? Well, interestingly, you will see H plus also cancels away, leaving you the overall electrolysis equation as water, giving you 2 times H2 plus O2. H2 is at cathode and O2 is at anode. So simply water is being electrolyzed, that's it. You get nice and happy O2 and H2 liberated at anode and cathode respectively. This is what which happens if you electrolyze dilute sulfuric acid. Last and the least, we have aqueous solution of copper chloride. If you have copper chloride at anode, first of all you have anion, and anion is chloride ion. Wow. So chloride ion undergoes oxidations and liberates chlorine. Please remember, much of it is chlorine, but chlorine is, a difficult gas to liberate. Sometimes, as concentration of chloride ion decreases, partly water can also undergo oxidation, liberate O2 and H+, but that is not a major reaction initially. We can simply write down, we have chloride ions giving you chlorine, and at cathode, you have those most loving copper ions which are shamelessly getting reduced to copper. So you have CuCl2 giving you Cu plus Cl2. That's a stupid reaction. Copper chloride as a compound on electrolysis it deposits copper metal at cathode and it liberates bubbles of chlorine gas at anode. That is what which happens. So dear students, this was a fascinating discussion of the most interesting of all and probably the most feared of all chapters, and that was electrochemistry. Not just the solutions have been covered, I repeat, I have also tried to give you insights into various workings of theory. It is full with so many tips, so many tricks, so many concepts that if you actually go through these solutions and discussions, you're bound to find them very useful and very, very enriching. Do comment and write down how you find them. If you like them, of course, press the like button, and don't you forget to share this with your friends and everybody you know about. Subscribe, like and share. Have a great time. Bye-bye.